All of the problems covered in my videos can be downloaded at statisticsworkbook.com. If you go to the website, click on the PDF. You can download a copy of the workbook for yourself. Also on the website, you'll find links to all of my statistics videos, not just the ones I've uploaded to YouTube. I've uploaded nearly 100 videos that you cannot find on YouTube. So, I do hope you'll check out statisticsworkbook.com. Alright, let's begin our problem. Hello, welcome back. So this is another exercise looking at sampling distributions of p bar. Not a lot of context here. We're just going to throw some numbers into some formulas, calculate some probabilities, and see what we get. So here we've got a generic population proportion is 0.45 and a sample of 150 is taken, and we're going to calculate probabilities that our sample proportion is either within 0.02 of the population or 0.04 of the population proportion. So we're just going to get straight into some of the calculations here. So what we're doing, let me write out our two distributions here. We have our population distribution, mean is 0.04. We have our standard normal distribution, mean 0. And we're going to convert information from that population distribution so that we can compare it against the standard normal. Now, for part A, we're looking at a distance of 0.02 from the population proportion. I'm actually going to just put P in here. So we've got this range, and I want to know what's the probability that we're within that range. So let's call this P2 and P1. So I want to know the probability that my sample proportion is between P2 and P1. Well, if we standardize that, I can obtain here the z-scores, Z2 and Z1, and now I can figure out, well, this probability of interest is going to be equal to the probability of a z statistic between Z2 and Z1. Now, to calculate that probability, what we need to do is figure out what is the probability that corresponds to Z2, and this is the cumulative probability. Remember those tables, they're always giving us the cumulative or the probability to the left of our value of interest. So I need to figure out this probability, which is our probability that z is less than or equal to Z2, and then we need to subtract from it the probability that z is less than 0.1, and that leaves us just that yellow space, which is our probability of interest. So this is minus the probability that z is less than or equal to Z1. Almost running out of room there. Okay, so let's get to it. We need to figure out what Z1 and Z2 are, and we need to figure out our standard error. So let's get the standard error first. Let's squeeze that in down here. So our standard error, this is equal to the square root of P times 1 minus, 1 minus P over our sample size, which we're working with a sample of 150. So we substitute in our probabilities, 0.45, 1 minus 0.45 over 150. And so this gives us a standard error of, where's my calculator here, 0.45 times 1 minus 0.45 equals divided by 150 and square root 0.04. So I'm just going to scribble this up here, 0.040. Okay, so there's our standard error. That's going to be the same for both parts A and B. So now let's figure out our z's. So our z, these distances from the mean, the distance between Z1 from 0 and Z2 from 0, they're exactly the same, right? They're the same here and here as well. That distance is what's given to us. plus or minus 0.02. So when we're calculating these z-scores, that's the only information that we need, is that 0.02, plus or minus 0.02. So this would be plus or minus 0.02. That's that distance, right? P minus P2, or P1 minus P, right? That's the difference that we're looking at in the numerator, divided by our standard error, which we've just calculated as 0.04. So this gives us a value of, I think I know what this is going to be, 0.02 divided by 0.04, so 0.5. 0.5 plus or minus 0.5. So for part A, we're looking at plus 0.5 minus 0.5. And so all of these values, Z1, Z2, here I'm looking at less than 0.5 but greater than negative 0.5. So I need to find these probabilities that correspond with plus or minus 0.5. So let's go to our tables. So these are other messy things from here. Let's look up our positive 0.5. So there's positive 0.50, so 69.15. So this one here, 0.6915 minus, now we want to look up our negative 0.5. So coming up here, our negative 0.5, and that third decimal place is 0, right? Because Z is 0.050. So that's why this third decimal here is 0. That gives us a value of 0.3085. 3085. And so that difference will give us our yellow space, our probability of interest, 0.6915 minus 0.3085, 383. So there's our answer there, 0.383. Okay, so that's the probability that if we take a sample of 150, we'll be within 0.02 of the true population proportion. Part B, now all of the same calculations, but we change that difference to 0.04. So this distance over here is 0.04. This difference in the numerator, 0.04. So we'll need to recalculate all of our z values. Thankfully, the standard error doesn't change, so we don't need to recalculate all of that. Let's get rid of this, and this, and this, and this. So let's start from scratch up here. So my z-score, now that difference, plus or minus 0.04, divided by the standard error, which hasn't changed, 0.04. Well, that's a straightforward calculation. Now, this is going to be equal to 1. Plus or minus, of course, because we're looking at either side. So there's positive 1, there's negative 1. So there's negative 1, positive 1, positive 1, and negative 1. So there's no surprise. We've doubled the width of our proportion, so the value of that z-score doubles, given the standard deviation, standard error is unchanged. So now, again, same exercise. We go to our tables, and we're looking up 1 and positive 1. So let's go to the positive side. There's positive 1.0, and again, that second decimal doesn't change, so it says 1.0. So there's 0.8413, 0.8413 minus, now I'm going to look up negative 1, and so there we are there, 0.1587. And so that difference gives us 0.8413 0.8413 minus 0.1587. Whoa, something went wrong there. Can't have a negative probability. Minus 0.1587. Good, 6826. 0.6826. So as my interval gets wider, the probability that my sample proportion falls within that interval, the probability increases because my interval of interest has increased, right? This is looking at, here in our z distribution, plus or minus 0.1, compared to this, let's say this is plus or minus 0.5. So there's a there's a higher probability that my sample proportion will fall within a growing or a larger interval. So hopefully that makes intuitive sense. If we increase our tolerance from 0.02 to 0.04, the probability, the likelihood that my sample falls within that interval is going to be higher. Okay, so hopefully that helps. Thank you so much for watching, and see you again next time. Thanks. Bye-bye.